This is an atom. Any element from the periodic table, like oxygen, nitrogen, or phosphorus. Now, this is a molecule, which is made of multiple atoms. These atoms can be the same, like in nitrogen gas, or different, like in water. These molecules can also be displayed like this. Hydro means water, while philic means love. So hydrophilic describes molecules that love and are attracted to water. These molecules are polar, meaning one side of it has a positive charge, while another side has a negative charge. This is because of the uneven electron distribution in the molecule. Take water as an example. Oxygen and hydrogen are bonded with one another, sharing their electrons. Oxygen is greedy though, and hogs more of the electrons, making it slightly negative, while hydrogen is slightly positive. This makes water a polar molecule. The reason why oxygen is greedy for electrons, though, is because it has a high electronegativity. Electronegativity is one reason why molecules are polar. It measures how strongly an atom attracts electrons. If an atom has high electronegativity, the atom will be greedy for electrons and hog them. If an atom has low electronegativity, it will be easygoing and hold on to electrons very loosely. Naturally, polar molecules will interact with other polar molecules. Ever heard of opposites attract? Well, it applies in chemistry, because the negative side of a polar molecule will be attracted to the positive side of another polar molecule, exactly like magnets. The molecules don't share electrons or become a bigger molecule, but they instead form temporary bonds. These can be dipole-dipole interactions or hydrogen bonds. Dipole-dipole interactions are just the regular interactions between polar molecules, where negative bonds with positive. Hydrogen bonds, however, are a stronger and a more specific type of dipole-dipole interaction. Several conditions need to be met for a hydrogen bond to form, but to keep it simple, it involves a bond with a hydrogen atom. This type of bond is mostly seen between water molecules, giving water its unique properties. So if you were wondering why polar molecules are known to love water or be hydrophilic, well, it's because water is polar, and polar interacts with polar. Next is hydrophobic. Hydro means water, while phobic means fear. Hydrophobic describes molecules that repel water. These molecules are nonpolar, meaning they have no positive or negative charge. Because of this, nonpolar molecules don't interact with polar molecules, but instead with their nonpolar friends. That's why nonpolar molecules are known to be hydrophobic, because nonpolar molecules do not interact with polar molecules like water. This is probably why you'll see sugar, made of polar molecules, dissolve in water. But oil, made of nonpolar molecules, does not dissolve. Another real-time example of hydrophobic and hydrophilic interactions are in your cell membranes. Phospholipids that make up the cell membrane contain hydrophilic polar heads and hydrophobic nonpolar tails. These properties explain why the heads face water, while the tails are tucked away from the water. Okay, so let's review. Polar molecules are hydrophilic or water lovers. They have an uneven distribution of electrons, making them have a positive and negative charge. This allows polar molecules to interact with other polar molecules, whether through dipole-dipole interactions or through hydrogen bonds. Next are nonpolar molecules. Nonpolar molecules are hydrophobic or water voiders. They share electrons evenly, so they don't interact with polar molecules like water, but with other nonpolar molecules.